Everyone. So in the previous session, we saw the basics of image processing and how image processing is done using Python. In this session, we will see how face detection works using our cascade method. So in this method, we will be able to detect faces quickly if there is a person's face in an image. This is a face detection, not face recognition. So you have to keep this in mind that this doesn't tell you whose face it belongs to. It will just detect the face in the image. And for recognition, we really need a large data set and deep learning methods for recognition of the image. So let's see what are the main feature types that we will be using for face detection. So the first feature we will see is the edge feature, where you have the black against white background, either in the horizontal or vertical direction. Next is the line feature, where we have the dark against white on the sides, horizontal or vertical. Then next, we have the four rectangle feature that looks like this. So each feature is a single value obtained by subtracting sums of pixels under white rectangle and sum of pixels under black rectangle. Realistically, our images won't have perfect edges like this. So in this image, so in this slide you can see that the realistic image is on the right hand side. That is this image, and this is our ideal image. So in this, you can easily detect the edge over here. As you can see, there is a clear distinction between the black part and the white area in the image. So what we will be doing is that for calculating the features in this, what we'll be doing is we will take the mean of the dark region. So mean of this, oh sorry, I'm really sorry. So mean of this is 1 and the mean of this is 0, and if we subtract both of this, you will get 1 as a feature. And here, if you see that the mean of the dark region will be something and mean of the light region will be some value, and if you subtract both of these value, you will get 0.6. So for the feature to be better, to perform the face detection better, the feature needs to be close to 1. So uh, ideally, as you can see in this image, your mean comes to closely to 1, but here you can see that our mean is calculated as 0.6. So if we do some calculation, or if our image is can clearly distinguish the difference between the dark region and the light region, it can give us a mean which will be close to value 1. So next is calculating these sums for the entire image would be computationally expensive. As you all know, images contain millions of pixels in it, and if we need to calculate all those things, we need to first calculate the mean, and then we have to subtract it. It would be a tedious task for the computer itself. So we have come up with a method that is, we will be solving this using the integral image method. So in the integral image method, over here on the left hand side, we have our original image. So this, I'm giving an example of what integral image actually does. Integral image method, what it actually does. So on the left hand side, we can see that we have our original image with their original pixel values. So this pixel has a value 31. The second pixel has the value 2, 4, and so on and so on. So if you see that what an integral image method does is that it chooses one value and adds them like this. So first we have the pixel value as 31. On the right, as you can see that the pixel value is 2. So we'll add them up, and like this we have 33. If we add 4 to 33, we will get 37, and if we add 33 to 37, we will get 70, and so on. So like that, we will calculate our integral image. So you will get an image. So you will get a integral table, or integral means some area table like this. So now what I have done is, so now you have to see the beauty of this method. Okay, so you can see a red box here. So in this red box, if you calculate the sum of all these numbers, you will see that the sum comes to around 101. So what the integral image does is that it tells us that what is the whole sum of this box. So the right hand bottom side pixel value tells the total pixel value image, means pixel value in this box. So similarly, 255 shows the total sum of the value of pixels here in, as the inside the green box as shown in this slide. So if you add 31 to 4 3 33 5 12 26 so on, you will get 240 254. And similarly in the blue box as shown highlighted here, you will get this 186, and similarly on the yellow box. So what it does is that if now I want what is the image, what is the sum of this purple box, what I can do is that first I know that the yellow box sum is 450. So instead of adding all this 15, 16, 14, 28, 27, 11 individually, and that sum will be around 111. So instead of doing that, what I can do is that if I know the sum of this yellow box and this yellow box sum, I know that it comes around 450. And if I add 450 and the red box here, it will come around, it will be around, I don't know, I haven't calculated. I will see. So just a second. Okay, so 450 plus 101, I will get 551. And if I minus the green box and the blue box, I will get this sum. So without individually adding the sums, without individually summing the pixels individual value, we can get this value by the subtraction of these boxes, which the computer is very good at. So this was the what do you mean by integral image method, and this makes our computations very fast, and it becomes easy for the computer to do all the mathematical functions and all. So the algorithm also saves time by going through a cascade of classifier. So previously I showed you some of the classifiers. This means that we will treat the image to a series of these classifiers based on simple features shown earlier. Once an image fails a classifier, we can stop attempting to detect a face, and it will say that the face is not detected, or else it will be means there will not be a face of any person. It will be just another image or something like that. So now let's see how this detection of face is done. So first we need is a front facing image of a person's face. So we have to keep this in mind that for our face detection method, the person should be facing front to the camera or the image. Then we turn it into grayscale. As in the previous session, I told that if you have a lot of information, when you have a colored image, you have a lot of information. So to compress or to reduce the information that we have, we convert it into different formats, like in grayscale or in binary. So in this case, we will be converting that image, that colored image, into grayscale format. Then one of the very first features searched for is an edge feature indicating eyes and cheeks. So what this edge feature do is that it detects the eyebrows of the person. So what it does is the black portion sees the eyebrow area and the white portion detects the skin area. If the eyebrows or the eyes are detected in the first go, then we continue to detect the face. If there is no such detection of eyebrows or eyes in our image, then it will say that image is not detected. So in the second, so if as I told you, if the image were to fail for the search of this feature, we can quickly say there is no face. If it is okay, if it is passed, then we search for the next feature, such as the bridge of the nose. The bridge of the nose is detected using the line feature, as I told you earlier. The this this feature detects the nose area, and like this, we continue to give a cascade of all these features, and we give around thousands of features to detect all the details of the face and to detect if there is a person's face present in the image or not, until the algorithm detects the face. So we will say that if the face is detected, I need to show that face with a boundary, with a square box or rectangle or something like that. The downside to this algorithm is that very large data sets needed to create your own features. So as I told you, there are thousands of features to detect the facial details and to capture all those things. But however, we are very lucky that we have many pre-trained sets of features already existing with us. So OpenCV comes with pre-trained XML files of various HAR cascades. Later on in the deep learning section of the course, we will see how to create our own classification algorithms for any distinct group of images. Till here, is there any doubt on how face detection is done? If there is any doubt, you can comment in the chat box, or else I will proceed. Okay, so I don't think there is any doubt. So let's proceed. Okay, so now we'll see the face detection program. So we'll start the face detection program in our Google Colab. Uh, So first what we'll do is we'll install a library. This library is known as pnslib. This library is in GitHub. So first we will say that in this line, what this line tells is that from GitHub, I have to clone that library and all the contents from that library. So I will say that pip install git plus git, and from GitHub the PNS 2019. From that, I want the PNS library. From there, this line is optional for you. If you want, you can use this line, or else I will show you how to upload your own image. In the earlier session also, I showed you how to present your or how to upload your image using this function. So my Google Colab has been connected to my net. So now I will execute my first function. So as you can see, it is cloning from GitHub, and it is cloning all the documents and all the libraries related to face detection in our drive. So here you can see the lena.png image is also saved in our Google Colab, and this was the first step. Now second step, what we will do is the basic imports of all the libraries and functions which we will be using for detection of the face. So first we will import CV2, as always, import CV2. From PNS library, we will import the utilities which we will be using for getting the HAR cascade XML files from the GitHub, which has been stored in our Google Colab. So for that we are using from TNS library import utils, and then for plotting of the image we use matplotlib.pyplot as PLT. So now we will read the image. Image is read when we use object here img. So that object tells us that we will be reading the image using the function cv2.imread. Uh, it is a cv2 function and it reads the image where it is stored from. So here I have that lena.png and it will be stored in this object. So now we will load all the face cascade and eye cascade XML files from the drive. So I will create an object here as face cascade. Face cascade is equal to cv2 dot cascade classifier, and from the cascade and using the cascade classifier function, we'll say that from the using the utilities dot get function, I need the path of the har cascade frontal face default.xml file. So this XML file tells you this is a pre-trained data set which I told you earlier in the slides that we will be using for detection of the face. So that we will get using the utils.get har cascade path function. And in this, what we'll be doing additionally is that we will also be detecting the eyes in the eyes in the image present. So we will say that we will be creating an object eye cascade, and similarly using cascade classifier function and using utils.get har cascade path, we will be getting the path of har cascade eye.xml file. And okay, then what we will be doing is that the first part as shown in the slide. First, we'll convert the colored image into grayscale format. So we'll be saying that we'll be creating an object called gray, and in that CV2, whatever image we want to detect the face from that image, you have to convert from blue, green, red to gray. And this faces this faces is used in capturing the means for the rectangle function we use faces. So face cascade detect multiscale. In that we will be saying that it should be in gray format. This converts into grayscale, but in the previous session as I told you that when it converts into grayscale, matplotlib shows the image in a perceptual uniform format, which is for colorblind people. So what this tells is that I have to convert that into gray so that I can see so that the computer can see the gray in this. And we will use a for loop so that when you give a face, in that face you can, when you detect a face in that, you can create a rectangle of your choice. So that rectangle should be of uh, length and height x and y. And this code here tells you that it will be using the uh, that uh, the image, the integral image or the summed area table method, which I told you earlier. So you will first give the whole image like x and y, and then using the function w and h, you will tell the computer that it is an integral image format. And here 25500 tells you that it will be in green, it will be in a green color. So so I want the rest of the color channel to be in to not to be detected. So I will make them 00. And That's it. And for the eyes also, for the detection of the eyes, similarly, I will create a for loop. In that, I will say that eyes, oh, sorry, I'm really sorry. This face will be detected in blue because BGR. So this will be face will be detected in a blue color square, and eyes will be detected in a green colored square. So after detection, it will tell that BGR that from matplotlib to CV2 conversion, I need that conversion here, and I have to show the image. So PLT show. And if you run this code, you will see the Lena image. The face has been detected using the blue color and the eyes have been detected using the green color as shown. You can also use any type of image in this. So if you want, you can screenshot this code because this is the main code. Or if you want to type, I will give you some time to type and see for yourself. If you have any doubt, you can uh, comment in the chat box. Any doubt, if anyone have joined late, they can also ask their doubt. I will rectify them. Till here, everyone is with me. Hello. हाँ.
हेलो.
Yes,
हाँ
yes.
अबे राम सुन ना देख ग्रे में ये जो कोड है सर्च फॉर पे ग्रे इज
Hello.
इक्वल्स
हाँ, एक.
where the code goes gray comma 1.3 what the 1.3 denotes.
Okay. So this 1.3 and 5, what I have done is uh, during face detection, if you have many faces, see, group photo, if you put a group photo, I will show you that. If you put group photos in there, there will be multiple faces. And detecting that face will become a task for that. So, 1 minute, I will show you that thing. Very good. मेरे को वही पूछने का means I just needed to clear your doubt. Just a second. एक मिनट मैं आया. Okay, hello. Am I audible now? Okay. Okay, so there's a good question from Abhinav. What this 1.3 and 5 indicates? This 1.5 indicates the scaling factor of the images, and this 5 indicates what we call is the minimum neighbor. So when we go for detecting multiple images, when we have an image where we have 10 people or 12 people, you need to adjust your scaling and minimum neighbors. You means this is experimental, or we can say it is random. So for my case, for detecting my image which has 8 to 10 people in it, I got better results using this 1.3 and 5. So if you need to know more about this, you can also go into OpenCV website and see in the HAR cascade classifier section there, and you will see for different images having different number of people and different faces. There are some patterns or things like that. So what I will do is quickly give you one example of detection. So I will be detecting this image. So this is a image of APJ Abdul Kalam, uh, and I will say that I'm changing my image. So I need to say apj.jpg. Make sure that you give the correct name. So I've given the correct name. This is fine here. And you can use this code for any image you want, and it will detect the same. So now, as you can see, this image of mine is very huge. It is some 2500 and having 2000 some height and width. So that is why my box is coming light here. So if you want to make that thick, so the box thickness is shown here 2. So if I make it 10 or 10 here, and then I run my code, it will become, yeah, you can see. You can also see it is by mistakenly detecting here and here. So this is a little buggy, but it does the basic job of detection. As I told you earlier, also while explaining you in the slides, that this is not, we are not using deep learning or any machine learning algorithms. We are using simple mathematics and Python programming language to detect the face. And now if I want to see a number of group, so this is an image of the scientist, the Solvay conference, very famous. And now if I change the image to scientist, okay, so now if I execute this, you can see that it is detecting the face of every scientist properly, but the eye thing is a little buggy, and in some cases you have to change. So that we have to change using multiple, like we have to change this 1.3 or 5 settings. And as you can see here, the person is not means seeing front of the camera, and is showing his side profile. So that's why the algorithm is not able to detect the face properly, and rest everybody else's face has been detected. So that's it for the face detection part. And this was some basic how we do image processing in using Python. And yes. So next, what we'll study is about, oh, give 1 minute. So next, the main topic, the main focus, our workshop. So now we will see something. Till here, everyone is with me. Everyone has written the code or grabbed, I mean screenshot सब ले लिया है ना सब लोग ने. Till here, any doubt? Detection part. What is HAR cascade? Integral image क्या रहता है? Summed area table. Okay, so respond to the chat box. Chat box is clear. Okay, so let's go ahead now. So let's start with the machine learning. We'll be not we will not be going much in deep into machine learning, but we will know the basics, and this will be enough for you guys to start or to code your own machine learning programs and algorithms. So here what you can see is the basics of dog versus cat. So you can see there are many there are many pics of dogs here, and here you can see there are many images of cat. And let's take the example of difference between cats and dogs. So for humans, it is a very easy task to tell the difference between cats and dogs. Even a child knows the basic difference between them. So so we know that if the dog so we can tell the difference between a dog's image and a cat image. We know that the dog has a particular shape or pattern of nose. It has a particular pattern in their eyes. Their ears are droopy, and they are means mostly everyone is furry and all. So, like that, we classify dogs, and cats. We can say that they have whiskers. So that is the main classification pattern. They have a slightly different eye pattern from dogs, and they have ears pointy. So that's how we as humans differentiate between cats and dogs. But if we want the machine or computer to tell us the difference between them, we need to code a very lengthy program for that. So if we go with the traditional programming method, as I explained you in the previously in the har cascade method, I told you that we need a long list of features, pre-trained features we want. We need a large data set, and we have to provide that data set into computer, and then we detect the face of a human or some cat or a dog, like that. So the machine learning totally changes this perspective. So I will quickly tell you what in traditional programming methods we do. So in such methods, we have a set of data with us, and we'll be using some set of rules. So so in the traditional programming, if I have a algebraic expression with me, so I have a lengthy equation, and if I have to solve that, or if I have to make a program that solves any particular equation, first I need to know what is basic board mass. So I need to know the rules. So the rules that we provide here, for example, is board mass. If I have to what you call if I have to make a application or a software that runs or that solves our equation, and then if I have the rules, if I give the data to the program, then it will use all the rules, and then it will tell us that if I have a bracket, first I have to open that bracket, then I have to divide, then multiply, then add and subtract, and so on. So that is our traditional programming method. So in machine learning, what we do is that instead of the programmer figuring out the rules, we will give answers. That is what the output should the computer predict. So instead of giving, it means if in the case of predicting the difference between dogs and cats, instead of telling the computer that if you want to detect a dog, you need to search for droopy ears, or you need to search for a particular pattern in the nose or something like that. What we will be doing in machine learning is that we will give thousand or a very large number of data to it. So in our case, we will say that we'll give thousands of photos of dogs to to our machine, and we will say that if we want to detect if it is a dog or not. So that is the data part. I mean, that is the data. So what the machine will do is it will predict some patterns in it. So it will detect that after comparing each photos, and it will search, it will scan the thousands of photos that we provided to the computer, and it will see a particular pattern. Like it will also come to know that there is some feature that is distinguishing the dog with a cat, and the dog has some this X and Y features that we need to detect in in for the detection of the whole dog or cat face. So that is what machine learning approach does. And so in ML, what a computer does is that it finds some patterns when we provide it with a lot of data. And after finding these patterns, it will tell us the difference between dogs and cats in our example. So as you see, if I give an image of a cat, it will have some binary code, key, this, some particular code for cat, and it will label that image as cat. And if I give an image of dog, it will have some particular pattern and it will label that image as a dog image. Okay, till here, everyone is with me? Basic machine learning. What do you mean by machine learning? Everyone is clear with that? Any questions? Okay, so I think everyone is with me. So let's move forward. So now is the Hello World program, which will be under machine learning. So if you need, whenever you start any programming language or any computer course, you go first with a Hello World program. In that, first you will see how to print Hello World. But in the machine learning scenario, we will be seeing a different approach here. So this I need answers from you. So this is an image I'm showing to you. So there is some value of X and there is some value of Y. So I need you guys to tell me what pattern you can see here. I need the relationship between Y and X. Means what is Y in terms of X? That is the hint I will be giving you. You can unmute yourself and answer me. There is some pattern you can see between X and Y. I think 10 standard mathematics, arithmetic progression. I don't need, uh, means I will clear that. I don't need the relationship between these two numbers. I need the relationship between these two numbers. These two numbers, these two numbers, and these two numbers. You can unmute yourself and answer me. What is the constant pattern that you can see in these numbers? Like -1, -3, 0, -1, 1 and 1, 2 and 3, 3 and 5, 4 and 7. If you are getting confused in this part, you can also see this part. It's very clear in this side.
Y is equal to twice of X minus 1.
Correct. Very good. So this is the relationship between both this x terms and y terms. So what we'll be doing is that in the Hello World program, which we'll be doing today, we'll say that I have a set of numbers in X, I have a set of number in Y. The machine will see all those numbers, and then the machine will predict what is the relationship between these two numbers, X and Y. And then if I say that I want the 10th number here, so it will say the 10th, if I put the 10 value here, so 10 to 20 is equal to 20, 10 into 2 is equal to 20, and if I minus 1 with it, I should get an answer 19 here. So if I provide the value of X to the computer, saying that if I give you the value of x, you should predict the value of y. So that will be the basic hello world program, which will tell you the basics of machine learning and deep learning. Till here, everyone is with me. We'll start the programming part. Or you have any queries, you can ask me. Any doubts? Today, I think was the most lengthiest part, but we finished it earlier. I think. Today we'll just end, or I guess we can also take one example if we have time. So till here, we everyone is with me. You can also type हाँ ना कुछ भी बोल सकते हो. I'm waiting. अच्छा समझ में आ रहा है, बोरिंग लग रहा है, क्या हो रहा है? You can tell me in the chat box. Okay, so no answers and no queries. So I think everyone has got what the basic idea is. So let's start with the programming. So again, Google Colab, and in Google Colab, hello. So basic machine learning program. Only how many lines? 1, 2, 3, 4, 5, 6. 6 lines of program. Hello world using machine learning. If you get the basic flow, or if you understand this, you can implement anything. And in the third day, we'll be using machine learning and image processing to see some projects, which will be very helpful for you, which will be very interesting. And I think everybody will get attracted to the machine learning and AI domain. So, all right. So now I will tell you some थोड़ा सा theory रहेगा इसमें. So bear with me. थोड़ा means I will just explain you what all things you need to know for this school. So okay. So as I told you, by feeding it with the x's and y's value, it should be able to figure out the relationship between them. So let's start with the inputs. So in the input, we first import the TensorFlow library, and we call TensorFlow TF for ease. We import NumPy as NP for mathematical, so means for functions, for doing our mathematical functions. Then from TensorFlow, we will import the Keras library. So this Keras framework is used for define. So this Keras library is used to form a framework for defining a neural network as a set of sequential layers. And that sequential layers, as you can see in this line of code, will create the simplest possible neural network, which will contain one layer, and that has one neuron in it, and the input shape to it will be just one value. So what this input shape tells you is that if I give the value of x, it should return me y. That's it. That the input shape, and units one means only one neuron should our neural network contain. So that's the basic, very simplest possible neural network that we will be creating today. And now, so I will just compile this, and I will create my neural network model here. So I will create an object telling that I will create an object known as model, and in that I will say that using Keras sequentially, I need a neural network which will have one neuron and it will take one input from me. And now when we compile our neural network, we have to specify two functions, that is loss function and optimizer. So we know, means before doing our coding, we saw that the relationship between the two numbers x and y is equal to 2x minus 1. But when the computer is trying to learn, it makes a guess. So maybe the computer will guess that maybe the function is y is equal to 10x plus 1. It can guess any random thing. So if it guesses 10x minus 1, I'm randomly taking an example. The loss function, what it does is it measures the guessed answers against the known correct answer and measures how well or how badly it did. So what it will say that how close the guessed function or guessed equation uh, is compared to our actual, means y is equal to 2x minus 1 function. So if the computer guessed 10x minus 1, 10x minus 10, so the loss function will say how close it is or how badly it did, and it will tell the optimizer function. And what the optimizer function does is that it makes another and better guess. So based on how the loss function went, it will try to minimize the loss. And so in the second time, the machine will say that I'm guessing, the loss function will guess y is equal to 5x plus 5, which is still pretty bad, but it is closer to our correct result. So it will repeat this for a number of epochs, which you will see shortly. But first, here's how we tell it to use mean squared error for the loss and stochastic gradient descent (SGD), as we used for the optimizer and loss function. So what this SGD and mean squared error is, this is basically statistics. So a lot of statistics and maths is used while we do machine learning and image machine learning and deep learning. And if you want, so it it is not necessary for you for now to understand the math for these, but if you want, you can search for them later, or else I can also give you more information later. And over the time, you will learn the different and appropriate loss and optimizer functions for different scenarios. For this scenario, I am okay with the SGD function and the mean squared error, which is a statistics or a mathematical function which we will be needing for our pattern prediction and so on. So now I will compile this and this line. So we'll now provide the data the computer needs for machine learning. So next we'll feed in some data. In this case, we are taking 6 x's and 6 y's. You can see that the relationship between these is that y is equal to 2x minus 1. So where x is equal to minus 1 and y is equal to minus 3, if you put the value of x in the y function, you will get the value of y. So the Python library NumPy provides a lot of array type data structures that are a de facto standard way of doing it. So we say that we will be creating an array. So previously, in the previous session, we saw how to create an array using NumPy, and in this also similarly, we will say that we are creating an array, and in that array, the data type which we will be using is a float data type, because we see that 0.0, 0.0, 1.0, and so on we are using. So that's why we are using a data type float. And when I execute this, so this is the data which will be providing to the machine. So again, I'm saying in the machine learning method, as we saw, we need to provide some data in it and answers to it. So that answers is getting predicted using this model.compile thing over here. This will predict what the uh, what the rules should be to predict what the value of y when we give means what the value of y should be when we give the value of x to our machine. So model dot fit, now here we'll see that now we have to train our neural network. So first we have set it up our neural network using the model object like tf.keras sequential function. Using this, I have set my neural network. Now I have also given the data to our neural network. The only thing to do is now I have to train my neural network, and the process of training the neural network where it learns the relationship between xs and ys is the model.fit call, as we have done here. This is where it will go through the loop we spoke about above. As I told you earlier, the epochs or the number of cycles which we'll be using for training our neural network. So it will go through the loop and it will make a guess measuring how good or bad it is, using the optimizer to make another guess, etc. It will do it for the number of epochs we specify. So here I have specified that I want 500 times the data to be executed, and it will guess the prediction for 500 times, and it will guess how good or bad it has. It will what you say, it will optimize, and it will say that how good or bad our uh, this is prediction is. And when you run this code, you will see the loss on the right hand side. So when I run this code, you can see that epoch 33 times, 96 times, 500 out of 500 times, and these are our losses. So I will come to this first. It will do the number of epochs, and I will also be telling you why this is taking time like this. Okay, so here you can see above, when it first predicted the value, the loss was very high. So what it does is, finally we need the loss to be very, very small. We need accurate and precise data to be predicted. And as you can see, after each epoch, the loss is getting smaller and smaller as we uh, go. And when we finally do our 500 iteration, we will see that it is some very, very small, and we'll see that it is around 2.4983 into 10 raised to minus 5. That small error I have made now. And now, as I told you earlier, if I want to check that if my neural network is able to predict my data or not, I will say that print model.predict, and I will say that if I give the value of x to be 10, what should be the value of y? And now if I compile this, it will show me an answer. But as you can see, we predicted that the answer should be 19, because if we put the value of x as 10, and 2 multiplied by 10 is equal to 20, and if I minus the 1 with it, I will get 19 as an answer. But as we can see here, it is showing me 18.9854, which is almost, or I can say, equal to our answer which we predicted. But you as you can tell that I have always used the word predicts, and the and why I say this word is that remember neural network deal with probabilities. So given the data that we fed the neural network with, it calculated that there is a high probability that the relation between x and y, that is y is equal to 2x minus 1, but with only 6 data points we can't, means the computer is not sure that that's it, that y is equal to 2x minus 1 is the answer which we should or the machine should predict. So neural networks and deep learning and machine learning, all these things deals with probabilities and not yeah, certainties. So humans are certain because we have, means this neural network which we have created is of one neuron, and we have millions of neurons, and we have a very complex neural network with us, and it is and we can say with certain that after seeing only two data we can say that okay, we need answer to be precise, and we need answer close to 90. But here, as we saw that we have only given six numbers, or as we can say only 6 data points here. We just close this. As you can see, only 6 data points have been given in each x and y array. So what, as you work with neural network, you will see this pattern recurring, and you will almost always deal with probabilities, not certainties, as I told you earlier. And we'll do a little bit of coding to figure out what the result is based on the probabilities. So yeah, if you need to have a more precise or a certain value at the end of your neural network prediction, you need to give it some large data set. So that's where the name big data comes, where you need to provide a large number of data to machine so that machine can learn and it can predict the data. So big data terms come from there, that large data sets you need to provide, and so on. So yeah, it also depends on the functions which we are using. So for this case, optimizer and laws like SGD and mean squared error is fine for us. But when you go for high level machine learning and deep learning programs such as breast cancer detection or something like that, you need to know, or you need to use some really good and predictable, sorry, means very good models of neural network. And in that, when you go for some big projects, you won't be using one neural network. It will have some 12 layers in it. It will have some hundreds of neurons or something like that. So you need to have a very good model and for a neural network to create all these things. And I just want to show you that, as you saw that we have only one neuron with us, and for 500 epochs it took around, I think, 10 seconds or something. When you go for higher neural networks, like very complex neural network, and if you want to do at least 10, I'm saying at least 10, it will go for hours, or means hours, like uh, that is the time that a machine takes to learn. And for big projects it takes weeks and months for the data to be trained for our machines. Till here, everyone is okay? Everyone is following what I told you? Everyone understood what this Hello World program means? I'm really sorry. Chat box में आया था. Okay, yes. नहीं, अभी नहीं आया था, ये पहले आया था. Okay. So till here, everyone is with me? If you have any doubt, you can ask.
अभिराम,
हाँ
अगर इनके जैसे इपॉक्स 2000 पे चेंज कर देगा तो कितना टाइम और बढ़ जाएगा क्या? लाइक 10
हाँ
सेकेंड बता रहा है, 500 कह रहा है.
हाँ, see, if you increase the number of epochs, the time will increase. If you
And the accuracy
increase the
part of
number,
it,
हाँ
and the accuracy part of it, like now we got 18 point something.
हाँ,
And if we increase the epoch to
accuracy,
1000, then it will get better.
higher number of epochs doesn't mean you need to have high accuracy. अभी अगर
अच्छा.
तू तू ये कोड अगर तू देखेगा, and if you run this code, you can see बीच में you got 8.144 इधर दिख रहा है,
हम्म.
and means
या
310, it varies. See, epochs are done so that एक basic ये रहता है, एक standard number of epochs should be done for training your data to the computer. So अभी देख, मेरे को ये epoch में कुछ अलग ही मिल रहा था और पहले कुछ अलग ही मिल रहा है. So it varies. This we cannot predict. So sometimes while doing big projects, what the thing is, कि if we give the best number of model, see, if we create the best neural network and we say that we are using the best functions, it will 100% accurate रहेगा, ये रहेगा, वो रहेगा. And if we give it less time or less number of epochs to predict what the correct answer should be, it will give us some false positive or false negative. So in our case, so in our project breast cancer, it is really important for us to detect the area of the cancer. If we falsely say, if we say that अगर उधर cancer नहीं है, and if we say कि उधर cancer है, so that term is called as false positive. जैसा अभी in the case of COVID also you would have heard this term false positive and false negative. False negative says that you have the disease but it hasn't been detected by the machine or the instructor. In our case, while doing breast cancer detection using deep learning, the machine does all the things. And so that thing where you need to differentiate and you need to check that you have some specific or accurate precision means बहुत precision के साथ there will
basically
not
more
be.
amount of data will increase your accuracy
हाँ,
instead of having more number of
डेटा एक ज्यादा लेना पड़ेगा और बहुत अच्छा न्यूरल नेटवर्क बनाना पड़ेगा. So
Okay.
that's the important thing you need to know. And here too, ये तो मैं बस एक न्यूरॉन का बताया, and एक न्यूरॉन takes this much amount of time. Okay, and the beauty of using Google Colab is that everything is connected to the net. So what Google Colab does is that it has some specific GPUs and TPUs with it. Okay, so GPU term सुना रहेगा तुम लोग ने, कोई गेमर्स रहेगा तो GPU सुना रहेगा कि इतना 2 GB का GPU है या 3 GB का ग्राफिक कार्ड है, तो that is known as GPU. So what GPU does is that GPU does some specific task very fast. If you compare a CPU and a GPU, you will see that CPU can do a lot of things. ठीक है, तो imagine you have a truck और a ट्रेन का एग्जांपल लेते हैं. ठीक है, तो गुड्स कैरियर है. So CPU, we can say that CPU is like a train. It can carry a lot of things, but it will take a time. It means it will take time, and but it will do a lot of things. But in case of GPU, what the GPU does is that it does some specific task. Like it will only focus on some part. Like if I tell my computer that I just need the GPU for so in games we use GPUs for our graphic settings and all that, and it does that job perfectly and with accuracy and precision. So GPU, we can compare GPU as a race car. वो कम जन को लेके जाता है बट एकदम फास्ट है. इट इज वेरी मींस यू कैन कंपेयर योरसेल्फ कि जैसा एक ट्रेन रहेगा बहुत बड़ा, इट डज अ लॉट ऑफ वर्क, बट अगर एक रेस कार और ट्रेन को ऐसा रहेगा तो रेस कार ऑलवेज विंस. मींस वैसा मैं ये बता रहा हूँ. ठीक है. एंड गूगल कोलैब का क्या ब्यूटी है कि गूगल कोलैब गिव्स यू एक्सेस टू जीपीयूज which is connected to their means data centers. उनके data centers में GPUs सब है जो we can access. So even if your machine or laptop is old, you don't have enough RAM, enough storage, or anything like that, or if you are using a mobile and you want to do some image processing or machine learning or deep learning, you can use this Google Collabs platform for very means बहुत मजा मीन्स एकदम तगड़ा काम करता है गूगल कोलैब में. इन शॉर्ट बोलना चाहता हूँ. एनी डाउट्स? अच्छा ऐसा डाउट पूछो. जीपीयू टीपीयू जीपीयू और सीपीयू में फर्क समझ में आया क्या रहता है एंड व्हाई. एंड फॉर AI and deep learning, GPUs are becoming more and more famous, and people are using these GPUs not only for gaming purposes, but in the AI and deep learning field also. It is very useful for us, for data scientists and everyone when they use neural network and all these things. So इधर तक सब ठीक है. I think everyone is with me. Everyone is understanding the concepts and all. If you have any doubt, you can ask me. If you don't want to like unmute yourself and ask, if you are shy, you can also privately message me in the chat box. It's fine with me. इधर तक everyone is okay? Chat box में हाँ लिख दो बस. Yes, anything. I will move forward, and one basic task I will give. If you want to do it here and now and here itself, it's fine. Or else if you want to go home and work on it, it's fine with me. Okay. So I will come to the last part. And I think the session is over. Means जल्दी खत्म हो गया. 8 o'clock को ही खत्म हो गया. Okay, fine. हार कैस्केड, any doubt? Integral image क्या रहता है? All the concepts are clear. Model क्या रहता है? Because I am going to give you a homework, or you can also do it here and now itself. Okay, so let's move forward, and this is the last program, or you can also take this as assignment. You can go home and means you are at home now. Sorry, so you can do in your free time also. So I'll be sharing you this document which I have made. So I'll be sharing this document with you. In this, I have written everything. I have also put the screenshots and all, so that you know what, where everything is. So day 2, hello world, we have seen breast cancer detection, and one more project is there that we'll see in the tomorrow's session. And I just want you to take this thing, house model assignment, as a task which you can do now itself, or else you can also go home and do it for yourself. So what this house model assignment is that predict the price of the house based on the number of bedroom it has. So imagine if a house pricing was as easy as a house costs 50k plus 50k per bedroom. So that one bedroom house costs 100k, a 2-bedroom house costs 150. So keep this in mind. One bedroom ka means one room ka cost is 50k, and the rest of the house cost is 50k. So if you are choosing a 1-bedroom house, the cost will be 100k. A 2-bedroom house costs 150k, and etc. and so on. So what I would like you is to create a neural network that learns this relationship so that it would predict a 7-bedroom house as costing close to 400K, etc. I'm giving you a hint to make this simple. Your network might work better if you scale the house price down. You don't need to give the exact number like 400K, yeah, 500K or something like that. You can also give the number 4, and you can also tell that I can multiply it later with a multiplier or function like that. And I want it to predict that if I give a number of bedroom, like if I want eight bedroom house, what should be the house costing and what should be the means like what should be the cost of the house. So that's it from my end for today. So you can also contact me if you have any doubts in this assignment. You can contact me anytime. I can clear your doubts. So that's it. So for me, today's session is over. If you want to do, you can also do it now. If you want, like, you can also share your screen, and if you have any doubts or you have got any errors, you can rectify them. You can doubts clear कर सकते हो. Okay, so thank you very much. That's it for me today. So if you have doubt, you can just say, or I will just tell the host to close the recording. For today, it's over. James, आज के लिए हो गया. ये assignment दिया है. If they have any doubt, they can clear now, or else they can also ask me later or tomorrow also.